Alrighty. So we're going to move on since most people seem to have gotten to a reasonable point through all of this. So we're going to start talking about objects, constructors, and control flow in Kotlin. So like Maltz mentioned, you have these kind of ideas of objects. Oh, not to skip two. Why is that skipping two? Of these top-level objects. We talked about classes, and then we're going to go again into just some more like basic syntax for Kotlin. So where we left off basically just kind of declaring a basic class with a no-args constructor. And so now we're going to talk about actually giving a constructor to your classes you define. So your primary constructor actually exists as part of the class declaration. It follows the class name. And you can basically treat it like any kind of parameters like you would in a function in Kotlin. So you give it a name, val or var. You define the type, and you can also give it a default value. These will actually be defined as properties in your class. So you can reference them as person.name later on. You can also define their visibility in line there with private, as well as do a couple other things like annotate stuff. And things like that, like you would expect with Java fields. Kotlin, because of how it declares these properties in the primary constructor, gives you a way to do your initialization like you would expect from a normal constructor in Java. These are called init blocks, and they basically just allow you to initialize all the stuff needed for your class. You can have any number of these init blocks. They all run in order listed in the file. So you can do init1 and initialize a bunch of fields, and then do a second init later on when you actually want to use those properties that you initialized at the beginning. Not the most useful thing to have multiple, but it's there if you need it. Going on to next. Kotlin allows you to do secondary constructors. This is not like the case where Java where you need to overload your constructors since we have default values. This just allows you to provide a secondary constructor if you want to be able to pass in different values to instantiate this class. The secondary constructors all have to delegate to the primary constructor and do not actually define any properties in the parameters list. So you see there's no val or var, there's no visibility declaration or anything. This is the nice little feature of Kotlin with this named parameter for the function. And so we're passing the age into the primary constructor using the default value of the name. And then since we were provided a hair color, we set our property hair color to what was passed in. So we're going to go on to a quick little demo here. Hopefully this works. And we're going to kind of show a little crazy example that hopefully you should never write to show you kind of the order of how things work in terms of like how things are initialized. So let's see if we can, oh boy, don't do that to me. Can I turn on tools? Vim emulator, please. And then we're going to go to a Scratch file. Alrighty. And we'll make this. Yeah. Okay. So we have this. Yeah. So we have this couple classes here. We have a child and a parent class. They each have a primary and secondary constructor with several init blocks, as well as properties that are defined. One thing to note on init blocks is your non-null properties, and I think properties in general have to be instantiated by the end of the init blocks, or at least the last init block for the class. We'll go into later about delegation to try and get around some of those things like with activities. Oh, I don't know what I'm doing here. So at the bottom here, we basically call into the child's secondary constructor, and we're going to go through basically what gets called first. So we have this unit parameter, and that's going to initially, with a default value, print line. So this is actually going to be the first thing printed. We then delegate to our primary constructor, and much like the secondary constructor, the default value of this unit parameter is going to change and be the second one. We then delegate to our super constructor, super secondary constructor, I suppose. Same thing with the print line again. It's going to be third. Delegate again to the parent primary constructor, and we hit the print line again. And so now that we've got this, and we've gone through all these print lines, we're going to start basically evaluating the parent class and initializing that. To start off with, this property will be the next thing initialized. And then we're going to hit an init block, which will then initialize or print out this value. So the order of this is basically, like I said, just kind of chronological order in the file of properties, init block, skipping over constructors, and then going to the next property. So in this case, we'll skip down here, skipping the secondary constructor since the primary is setting everything up through these initialization blocks. Oh, whoops, that's my bad. And so this should be 7. Then we go into our secondary constructor and complete that. So this should be 8. Go back down to our child class, do the same thing where this property is initialized before the rest of the init blocks and other properties below it. So this should be 9. We hit this init block, should be 10. We hit the property, should be 11, 12, and then back up to our final constructor that we originally called. That should be 13. Hopefully I can make this run. Where's the run button? There it is. And I got this right, hopefully. Cool. Yeah, so you see the 1, 2, 3, 4, 5, 6, all the way through 13. And so now we can go back to this.
Any questions on this?
Yeah.
Was that confusing enough?
This might be slightly confusing. Not something you want to do on a normal basis.
What are properties that you were talking about?
So the properties, oh, whoa. Oh, that's fine. Yeah, that works for me. Okay, so the properties, okay, we'll come back to properties. We have a whole entire thing dedicated on it, but it's basically, oh, thank you.
There'll be an entire presentation about properties.
Yeah. So think of them basically as your typical Java fields you would declare in the Java class and you would instantiate during a constructor of the Java class. So moving on, we're going. Oh, he's got a question. Oh, wow, I'm sorry.
Cool. I'm wondering what the point of the init block is, because it looked like you can initialize variables like outside of the init block, anyways.
Yeah, so you can initialize certain properties and stuff, but let's say like you needed to print out like a whole bunch of stuff or call to the system to get some like variables that you didn't have. Like you can do some of that extra work that you might not need assigned to a property, or you might need to set up to make your class just kind of run.
Yeah, also the when you assign, the right-hand side of an assignment has to be a single expression. So if you need to do 3, 4 expressions in order to come up with the value that you need to assign, then you'll need an init block.
Okay. All right, pass the demo on to object. Okay, so as Maltz mentioned, we have this keyword, object. It's about as close as static you can get in Kotlin. And it's mainly used to basically just handle anonymous inner classes that we see oftentimes with RxJava, where you need to just basically declare a new implementation of an interface, as well as a singleton pattern. What's kind of cool is the object actually has a backing class behind it at runtime, which allows it to kind of just automatically implement this singleton pattern for us, so we don't have to worry about creating an instance variable, assigning it, and kind of doing that whole boilerplate stuff that Java forces us to. Object also allows us to have static methods on the JVM as well as static fields. You have to use a couple extra keywords. One of them mentioned before was const for your static fields. And then for methods, you'll see in a second here, we annotate that with @JVM static. That just kind of makes it like play nice with Java and kind of work as expected for like a static method. Every class on top of that can have what's called a companion object. A companion object is basically just an object, just that the backing class is actually the class that it's defined in. And so it makes it basically like static methods inside a class that you would instantiate. And so it looks pretty similar to that in Kotlin. One of the interesting things, again, with the idea of this backing class of the object, you can't actually inherit an object that's defined, but the object itself can inherit and extend. This gives a lot of flexibility in terms of like what we can do with it and applying things. We'll see an example here in a second. Nope. Come on. Okay, there it goes. So this is how you define an object. It can be placed pretty much anywhere. And it looks basically just like a static class or static like util class you would see in Java. So we define this field as well as a function. In Kotlin, it looks pretty much the same as you'd expect from just a static util class. You call the class name and then the static method and variables inside of it. However, in Java, it doesn't play super nice because it's not really a static on the JVM. So you have this instance keyword here that works, like I said, kind of like a singleton, which points to the backing class of this. We can make it play a little bit nicer in Java, though, using those keywords I had said before, using const for any fields that have a basic primitive type in Kotlin, as well as JVM static for any methods. And now it just looks like you would expect a basic util class in Java to look like. So we're going to talk a little bit about an advanced way of doing companion objects here. So in this case, we want to be able to have a couple of repositories that call to a network or to a database, but we want to be able to also just kind of mock it whenever we want to for testing purposes. So this is kind of hard in Java, and it's not like super hard, but you just kind of have to reuse this logic and type it everywhere, and you can't inherit this functionality from anywhere. And so what we can do actually in Kotlin is make an interface, a simple interface, just a factory. It takes in a generic. We bound it with type any. If you don't bound it with any type, it's actually any question mark. To explain question marks a little bit, question marks are a nullable type in Kotlin, since nullability is a first-class citizen. And so if you don't bound it by any, it can be any question mark by default. So we declare this mock variable, property, say it's nullable just because we don't always want the mock set. And then we have a function of just getting the instance of that object we want. We can then make a provider class. It's open so that we can extend from it. And it takes in an initialization block as its primary constructor. It's just a function that takes in no parameters and returns the object that we want and the generic defines. And it extends from factory or implements factory. We then override that property and the property mock, and we set it to null by default because we don't necessarily want to mock everything unless we're testing. We then have the instance property that we create ourselves. It is lazily instantiated, which we'll talk about a little bit later, but we basically call on that init block that's passed into us to get the value that we want for that instance. We also then override the instance method, and if mock is not null, which is this ternary operator, kind of looks like you'd see in Java, it's actually a nullability check. So that basically just means if mock is not null, return it. If it is null, then return the instance. And so now to get the functionality we saw below, we basically just have to make a companion object in these repositories. And then the companion object can extend from the provider. And we just define the generic as the repo that we want to return. And the initialization block we pass it is just a constructor of that repository. And so now, as you can kind of see below, it's a little grayed out. If you want to set the mock to use the mock when we're testing, you just do the repo.mock and set it equal to a mock of that repository. And so again, like I said, it just allows us to dry up our code and reuse like simple functionality across a whole bunch of different things. And so now we're going to move on to control flow, unless anyone has any questions on companion objects and things. We good? All right. So Java from the C days has this go-to statement. No one should ever use it. No one ever does use it, hopefully. But Kotlin just kind of explicitly got rid of it because it's a pretty frowned upon thing. There is still return, break, and continue like you'd expect from your kind of loops and other things. In this case, we're just looping over a list of 1, 2, 3, 4, 5. If we hit 3, then we just return non-locally the function, and so we just exit the function, and hopefully we all know that it prints 1, 2. However, Kotlin actually adds a little bit of functionality onto this to allow for local returns and control flow. And return, break, and continue can use labels. So in this case, we have an implicit label where we want to return to the for each. And so what this actually does is this actually brings us back to the top of the for each loop at when we hit 3. And so this actually works much like a continue in this case. We don't often want to use labels, but with a lot of the nesting and inline functions and other things, where we don't want to do a non-local return and exit the function that's calling us, this allows us to do like a local return and skip over things. So this actually prints out 1, 2, 4, 5, and then the last line that this is reachable. So like I said, it just kind of works like a continue. We can also define explicit labels. So this is the exact same thing as before. We just explicitly state the label is this loop. We give it a word or a name, and then we append it with the @ symbol. And then you can use your control flow stuff to return, break, or continue back to that location. You can also return a value to the label you go back to, but that's probably not something you want to be doing too often. It's kind of confusing. And so moving on, to give an example of like when we just kind of break out of something, this is purely contrived for just making a point. You can wrap this for each in a run block. And so when we return to the run block, we actually have already run through the for each, and so we break out of the run block and don't execute the next loop of the for each, and so we get 1, 2, this is reachable. Alrighty. And so like you saw before, we have for loops again, pretty typical things. Unlike Java and C, there are no parameterized for loops. So you don't have your int I, like I is less than 1, I++. That no longer exists. Kotlin provides a couple things to make sure you can get you can still have all the functionality you expect. You can use ranges. Ranges allow you to skip to go through the range multiple steps at a time. You can also use with index to get the index that the for loop is on. But just note that that doesn't really exist anymore. And there's a lot of useful iterable extension functions, which we'll talk about later, that help you basically handle all these cases. The while loop is the exact same as Java, so there's not much to cover there. And then the if statement is pretty much the same as Java, except we introduced this idea of an expression. So in Java, almost everything is a statement, which means that it just does something. It doesn't return anything. If it did return something, it would most likely be void. And so you don't get to like evaluate a lot of stuff. You just call something, it gets done, and then you move on and return the value you want to. However, in Kotlin, like a lot of other functional languages, you have this idea of expressions where an evaluation block can actually return a value to its caller. In this case, we're going to return whatever the last value is in the evaluated block. The last value in the evaluated block is what's actually returned back. You don't need an explicit return. You can also assign variables to this. So you could do val environment equals this if statement, and that will assign the environment to whatever is returned from the evaluation block. We'll see this in a couple other control flow stuff going on. So this is basically like how Kotlin will do its ternary operations like you would see in Java. The next kind of big thing that Kotlin introduces is pattern matching with a little bit better of a switch statement called when. To kind of help you understand it a little bit, when just gets compiled down to a bunch of if else, and then else blocks under the hood. So this just kind of is syntactic sugar around doing that. It just makes it a little bit easier to read and a little bit nicer to work with. You can provide when with a parameter, in this case, this Boolean that we had been using before. And each arm basically just checks to see how it evaluates. So if the JVM runtime is true, like we said, the last thing in the evaluated block is returned for this expression. So in this case, if the JVM runtime is true, then we return this runtime environment application. You have this else branch. This is needed whenever you're using as an expression, and it's not needed when you're not, and you're just kind of using this to evaluate some logic. The only time when you don't need it as an expression is when you use enums and sealed classes. We don't talk much about sealed classes, but they're basically enums where the compiler knows ahead of time that these are the only values that this can be assigned. And so the compiler can infer that all branches have been taken. That way you don't need to declare this else. Another thing that's switched from the switch statement is there's no fall through. So there is no, if it's this case, like in this case, do these two things, and it falls through to the next one, I need to call break. These are all individually evaluated, and all of the branches following aren't actually evaluated. It's just the one that matches. You can set, if you need to match on multiple things, you can comma delimit those matching values on the left side of that lambda arrow. You can also do a block here so that like if you need to do multiple steps and then return something, you can do it just like a normal if statement where you have a block of code that follows this. And so here's a case when the when is not actually parameterized. All this is again, just a bunch of if-else statements, and it just looks a little bit nicer. So basically, it'll just go through each branch, and whatever branch first evaluates to true, it will then execute the block of code following it. And then at the bottom, we just define an else that if none of the branches above evaluated, do this instead. And so finally, yet another thing that can be used in an expression is try-catch. It's the same thing as in Java. The one thing with Kotlin is that we don't actually have checked exceptions. So if a method declares that it's going to throw a illegal argument exception in Java, that's a compile time error if you don't wrap that with a try-catch and catch that exception. However, in Kotlin, the Kotlin compiler doesn't care. We treat it as unchecked exceptions, and so you don't have to wrap these calls with a try-catch block. It's still, if you know that there's a chance that something could go wrong and you don't want to crash at runtime, it's definitely still worth your time to wrap and try-catch. But if it's a really random error or the library using just kind of frivolously throws things just in case, you don't have to wrap everything up with try-catch everywhere. And like going back to what I was saying, you can again just use this as an expression. So we can try to get this class, and if we do, then we just set the isJVM runtime as true. If it throws an exception because the class doesn't exist or the environment variable isn't set, we catch that that exception, and then we just return false to this. And so that is the end of the control flow. Does anyone have any questions? Nope.
Can you go back to the when statement?
Yeah.
Is there, this is probably just a weird question, but is there a way, if this was parameterized, is there a way to combine just evaluating that parameter versus having like just cases like the other one where it was like X is odd? Is there a way to mix that, or is it just one way or the other? Do you know what I mean?
Yes, there is. So they're comma separated. So on the left-hand side of the arrow, you can put all the cases that you want to go to this block comma separated. So in this case, it's just true and false. But like if this was a number, for example, you could do 0, 1, 2, 3, 4, go to the first case, else go to the second case.
It pretty much just evaluates the first branch it hits as true. So, because again, like I said, it just compiles down to a bunch of if-else statements underneath the hood. So
this one actually doesn't. So this
doesn't?
one compiles to the most. Yeah, it may compile to if-else statements if it's the most. So this particular one will probably compile to an if-else statement just because it's evaluating a boolean. If it's evaluating something which can be a switch statement in Java, then it will actually compile into switch statement because they're a bit more efficient. But if you're, for example, evaluating a class and you do an instance of within there, then it will compile into if-else statement. So it really depends on what it is, but it will, like the Kotlin compiler will compile it into the most efficient thing in Java, which may be just a long spaghetti if-else statement.
Does the compiler compile it down to Java and then to bytecode, or does it directly compile down?
it goes straight to the JVM bytecode. So it obviously takes steps to make sure it interops nicely with Java, but it all just targets the bytecode, which is why you can decompile Kotlin or look at the bytecode of Kotlin and then decompile it back into Java. It just goes straight to the JVM bytecode. Alrighty. I guess it's time to try our hands at actually doing an exercise. This is hopefully a little bit more simple than what we were doing before, only because we don't have to fight Android Studio. But we should get rid of this, and we can take a look at app. Maltz did.
Start with up one. This is
Oh, yeah.
the one that I helped.
Okay. Yeah, that would have been very confusing. So if you don't have the main activity set up and stuff, don't worry too much. You can start from this app one state, where you just kind of, like Guest mentioned earlier, just have an app state after each presentation in case you didn't finish the exercise beforehand. So in this case, we're pretty much just going to create. Why does this keep happening? Okay. We're pretty much just going to create a fragment. It's just a simple case to show how we can use a companion object to create an instance of the fragment. Okay. All right. That works. So let's see. Android, where's my fragment? There's a fragment. Hopefully this doesn't. Oh, good. Fun times. This is a lot simpler because I don't have to set up all this stuff. So I need a Kotlin class, and we're gonna name this main fragment. Sure, why not? And then we can extend from fragment. And we get our companion object. And then this is fun instance. That should return like that. So this, again, just is like a static initialization method, like you'd see on a normal fragment. And this basically just creates an instance of the fragment for us. And so then we got to override our override on view created, if I remember correctly. On create view and on view created. So you can hopefully that this, oh, it doesn't like that. Okay. Make it a little bit more readable. So in Kotlin, when you you run over basically like line length, we wrap, much like Python does. And so it's a little bit more readable. Sometimes it can get out of hand. Sometimes constructors can be very long and it looks a little ugly, but it does make it a little bit easier to read once you start adding annotations and other things. Each parameter gets its own line, so it's a little bit better to understand what's going on. Since we just need to inflate this, it can just be a function expression. inflator.inflate. This should be our layout.main content, our content main. We need to attach it to the container, but we don't want to attach it to the root. Why did that do this? Oops. Okay. What are you complaining about? Oh, that's fine. And then we can override our create. Should be create view. And view created. There we go. And so then this just does that. God, what is it? And so then, just like in our activity, we can just do our text view, and then dot text equals our dot string dot greeting. Oh, what don't you like about this? Oh, whoops, toString. Get string. There we go. Okay, and so then we now need to go back to our main activity and simply just delete this. Actually, we'll need to add a frame layout. Frame layout. Just match parent. Match parent. Oh, down goes that. Alrighty. I don't think. Let's see. ID frame layout, sure. Should hopefully work. And then support, fragment manager, begin transaction, replace. This takes. ID dot frame layout, and then we can just do main fragment, and this looks just like a static call. Get the instance, and then we can commit that transaction. Alrighty, a little bit more readable. Cool, and then hopefully. Do we have tests on this? I don't even know if we have tests. Oh, we do have tests. Hopefully this test will pass. Oh, he didn't fix that.
You still need to turn off configuration?
Let's see, configure. Time to compile. Apply, okay. Hopefully this works. Oh, fun times. Okay, well, we'll just launch the activity then. Hooray! Nothing changed because we just added a fragment. Alrighty.
Cool. So I'd probably advise everybody to just start with app 1 and scratch whatever you... unless you really managed to do app, then continue where you were. That's great. But if you didn't, just continue what Kurt just did in front of everybody. Just continue from app 1 and try to just break down the activity into an activity and a fragment. There's also bonus task and things if you're a bit faster. Because we were much later on the first session, we're not going to start in 3 minutes with this next session. You'll have a bit more than 3 minutes. So we'll probably start at like 15 or 20 past. Again, if you have any questions, just raise your hand. One of us will walk up and we'll fix it. All right. Have fun.